So I gave you the tip that we weren't going to do 4 times 4, that we're going to deal with the exponents instead, and said that the first base has an exponent of 1. Bless you. And the reason why you can't do 4 times 4 is it's like the 4s are not available because this one has this exponent stuck to it. So it doesn't, you can't multiply in the regular sense. Although technically exponents are just repeated multiplication, but at any rate. So what we do instead is just rewrite this with the same base of 4, and we add the exponents. So we add the 1 with the negative 6. What does 1 and negative 6 give you? Negative 5, right? So we have 4 to the x minus 5 equals 4 to the 2x plus 3. And now that we have only one base on the left and one base on the right, we can do what? We can drop the bases and then set the exponents equal to each other. It's not that the bases are canceling out, it's just that because they're equal, we know their exponents, the values of the exponents also have to be equal to keep the equality or the equation in balance. And so then from here you just put your x's to one side, your constants to the other, and you get negative 8. Who got negative 8? Okay. So it's not really as tricky as it first seems once you just remember our exponent rules. I want to give you one other example. In this problem, everything, bless you, already had the same base. We didn't have to do any rewriting like we did last Friday, but let me give you something that does look kind of like that. Let's say we're going to still go with base of 4, but let's say we had this instead. Okay, so I have base of 4 on the right-hand side, but the left-hand side is weird. But your brain should be looking at the 16 and feeling like 16 and 4 are kind of related. How are 16 and 4 related? In what way? 4 times 4, and since we're working with exponents, how would you write 4 times 4? You'd write 4 to the 2, right? So we would rewrite that 16 as 4 squared, but then you still might be thinking, well, it's really not a base of 4 yet. It's 1 over a base of 4. And what's the property that tells us we can flip things? The negative exponent rule, right? So the negative exponent rule says I can rewrite this with a base of 4, and now what kind of exponent is going to have? Negative 2, okay? So you have to be able to recognize that negative exponent rule in the wild, in whichever form you find it. It's easy when we're given this, but when it's in this form, you have to be looking out for that, okay? And so now that the bases are exactly the same, you drop them and set your exponents equal and solve. Just solve normally, okay? Any questions about those? Yes, ma'am. Okay, do you want to see that? Like I can do that, I'll do that in a different color. So if you were looking at it and your brain saw that you could write everything with base of 2, that would go like this. It would end up being 2 to the negative 4. You're okay with that, right? But then on that side, that 4 squared, you'd have to rewrite as 2 squared, which is to the x minus 6. Okay? And then you would have to multiply those. So you'd get negative 4 equals, and you'd solve that. Okay? So that's the one thing about these kind of problems with so many different exponent rules. You could start a lot of different ways. As long as your math is fine, you'll come up with the same answer. Okay. Were there any questions on, this was from Friday, Friday's homework? Didn't we do Friday's homework? A couple. I liked this homework. These are my favorites. They're like little puzzles, like logic almost puzzles. They're fun. All right, so you can keep that out while you do your skill check. Here's our plan for today. We have a skill check, and we have a lesson, and then I'll give you your homework, and then I'll go over your quizzes from yesterday, which are graded. Friday? Um, why don't you just keep your warm-up out, look at the skill check, and see how you do. And if there's an emergency, just raise your hand again and let me know. We can figure something else out. Oh. You did that. Oh, here are the, don't look, Armando, close your eyes. How'd you do? Yes? Raise your hand if you got all of them right. All right, very good, very good. Raise your hand if you were just made a silly mistake, something little. Okay, that ain't no thing. Yes, yes. I will take that into consideration when I grade. Okay. Okay. These are notes, but I don't want to talk about them just yet. I want to show you something about why we're even doing what we're doing today, and you don't even need to write it down. Like, I just want your eyes and your ears for a few moments while I set this up for you. Friday's lesson was on solving exponential equations when they had the same bases everywhere. So in its simplest form, if we had something like this, how would you solve? What would you say? X equals 5, right? That's the simplest form. And then we moved on to something like, well, what if it already didn't have a base of 2? What if it looked something like this instead? We're like, oh, well, we got that. We'll just rewrite 8 with a base of 2, like this. And now we know that x equals 3. Okay, but that's for when you can rewrite things with the same base. If you had something like this instead, okay, 9 cannot be rewritten with a base of 2. And so we need a whole different skill to solve this equation. Because x is in the variable is the exponent. It's like stuck up there. We have to get it down so we can say x equals something, right? So what we need is the inverse of whatever's going on there, which is how we always solve equations. Because if I had something like this, how would you solve this equation? You would divide by 2. Because dividing by 2 is the inverse of what? Multiplying by 2. So to solve this equation, which is an exponential form, we need the inverse of exponential, and that is called log. All right? So we're going to talk about logarithmic functions today, and really all we're practicing is converting between one form and the other. It's just like a basic skill today. We're not applying it to anything. We will eventually solve equations using it, but today is just a practice on how to do it. It's you might have heard it sometimes called the lasso method, right? You've heard that? Okay. So going back to your notes then, this right here is just a general form for log, and it reads like this, okay? That's how you would say it out loud. You would say f of x equals log base a of x, right? So which one of those things was the base, by the way? Which one? A. The a. So when you're writing a log, the base goes down here. It's like a subscript, okay? It's a little bit lower than everything else. The x, though, is normal. It's not an exponent or a superscript. It's not anything. It's just even with the log, and the a is the base, and it's below a little bit. Because what will happen is I'll have a lot of people sort of writing this like it's a to the x, and that's not what's going on. And blah, blah, blah. Okay. So here's how this is going to go. On this part of your notes right here, these are just the general forms. We're going to practice the lasso, all right? It says make the log loop, okay, aka lasso, right? Because you all know what a lasso is, right? Like when a cowboy's like lassoing the thing. Is it? Is it in Fortnite? So we have this. Which form do you think this is, log or exponential? Log, it says log, right? Which one would this one be then? Exponential. Now that might seem like, oh my gosh, why is she asking us that? When we start getting into equations and they're mixed, that will be the first thing I ask you when you're stuck. Which form are you in? How do you get out of that form? So that will be this skill that we're learning today, okay? It's going to be one of those things when we get over the lesson, I give you your homework, and be like, I'm not even going to try that. But then when we get into more complicated problems, it'll be the first thing that you forget. Because you're like, wait, how do we do that? Right? So here's how the lasso goes. The first thing you want to do is you want to always begin with the base. So write this down and then I'll show you what it means. So you're going to begin wherever the base is, and you're going to loop around to the opposite side of the equation. Loop around to the opposite side. And this, the reason why I'm stressing the opposite side, because then no matter what form you're given, whether it's flipped or not, you know which way to go. So loop around to the opposite side of the equation. Okay, so you're going away from the base. So on that left side, which we said was in log form, what's going on here is that the x is hooked onto the log, okay? So to get x by itself, we convert over to exponential form like this. You start with the base, which is a. Remember, you're trying to go to exponential form, so I need the base with an exponent equals something else. That's where our goal is. You loop away to the opposite side of the equation, and you come back. And you just pick up the pieces as you go. So it's a to the b equals x. Okay, you're going this way. A to the b equals x. You can end up where you started with. Same thing on the other one. This is an exponential. I want to convert this to log form, so I can go ahead and just write down log, because I know this is my goal here. Okay. You start with the base. The base is here this time. You loop around the opposite side of the equation and then back to where you began. So it's log base a of x, that's the next thing you get to, equals the last thing you get to, which is b. Right? Start at the base, loop to the opposite side, and come back to where you began, keeping in mind the form you're trying to end up with, okay, whether it's log, blah, 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 or an exponential form. Does anybody need this screen up anymore? Okay, these are all, what form are these in right now? Log, so you need to rewrite it in what form? Exponential, and you're going to start with the base. You're going to loop around which way? The opposite side of the equation, right? And then back to where you started. So take a minute and try that. On this first example, what's the base? 4. To get to the opposite side, do I start left or right? Right. Okay, to go to the opposite side. So this becomes 4 to the 3 equals 64. And then check yourself here. Does that make sense, that 4 cubed equals 64? Yeah, right, because 4 times 4 times 4, 16, 64. The second one, here's the base. Now I'm going to show you wrong first, because then I want to explain how you could check it out to see how you did. Wrong would be just autopilot, and you just go to the right like this. And you say 81 to the 9 equals 1/2. But that doesn't make sense, right? 81 times itself 9 times will not equal 1/2. So let's redo that. And this is why I wanted to stress, go to the opposite side of the equation. Because if I'm going this way first, I'm staying on the same side. So I want to go to the opposite side and come around. So it's 81 to the 1/2 equals 9. And here's why that makes sense. 1/2 is really taking a square root, right? It's root 2. And so square root of 81 is 9. And then for this last one, here's my base. Do I go left or right? Right. So it's 10 to the -3 is this, which makes sense because it's a little bit scientific notation-y. Right, you're going 3 places to the left. All right, who got all those right? Who was a little bit confused, but now you're no longer confused? Okay, fabulous. So this was going from log to exponential. So let's practice the going from exponential to log. You're starting with the base. You're looping around the other side of the equation, and your answer should have log in it. Okay, so try those. Okay, log base b, blah, 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 blah. All right. Who's already done those? Okay. Does anybody just need 30 seconds to finish them? All right, so for this first one, here's the base. Do I go left or right to get to the other side? So it's log base 2 of 1/16 equals -4. I like the second one because obviously we know that e to the 1 equals e, right? But when you rewrite this in log form, log base e of e equals 1, those are canceling each other out. Okay, that's why you get the 1. So the log of the base of something, log base 10 of 10 would give you the same thing. Pretty much any two things there that are the same. Let's just give you 1. And then on this last one, you should have had log base 10 of blah, 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 100,000 equals -5. Questions? All right, let me give you your homework, and then I will pass out your quizzes and go over your quizzes.